TFET or tunneling field effect transistor is an experimental type transistor. It works on the basis of quantum tunneling, which means a wave function can penetrate through a potential barrier. And this is the major driving force of TFET. Now we can see a structural image of TFET where we see the drain and source are oppositely doped and the channel is intrinsic. In general case, the drain is doped N-type and the source is doped P-type. And now we also have two graphs which shows the off state and on state of TFET. Now, if we look at the off state, we see no applied gate voltage. So in this case, electrons can't move across the region because the energy gap between each region is too large to propagate. Now, if we look at the on state, we see if the gate voltage is applied, then the energy level of the channel is decreased in the energy diagram, and we see the energy gap between the conduction band of the channel region and the valence band of the source region becomes narrower, and the electron tunneling generates. As the energy gap gets narrower, tunneling probability increases. Now we have a TFET versus MOSFET graph where we see the structural difference and the graphical difference between TFET and MOSFET. In case of MOSFET, we see the source and the drain are similarly doped and the channel is oppositely doped. But in case of TFET, we see the source and drain are oppositely doped and the channel is intrinsic. Now, if we look at the graph, we see that the subthreshold swing of the MOSFET is larger than that of TFET, which means the subthreshold slope of TFET is larger than that of MOSFET. So we can say that as we have a less subthreshold swing in case of TFET, so we have a good on and off current ratio in TFET, and we can turn on the transistor by using a smaller voltage. So it can help us to reduce the size of transistor. We can use TFET basically in low power integrated circuit as they have greater speed due to tunneling. Now TFET based biosensor exhibit improved sensitivity over many other sensors. Moreover, many companies are doing their research to make more efficient DRAM using TFET. Here are the references from where I completed my presentation. Thank you.